Hi, folks. Hope you are doing well. Today, we are going to be learning how to balance equations. I used to live in New York, as many of you know, and in New York, they have this museum that called the Transit Museum, where you learn about the creation of the New York subway system. And they started digging this tunnel or the tunnels for the New York subway system in the late 1800s. And it finally opened in 1904. It was a massive project for the time. Here's one of the first subway stations that opened at City Hall. It's no longer in service, but if you ride a special one of the subway lines all the way to the end, it still takes you through this subway station, even though you can't get off. And it's almost like an abandoned subway station. It's very cool. I highly suggest you look for that if you ever visit New York. When they were building the subway, they used miner hats like these. And they didn't have battery operated lights. They had to use lanterns that had a flame here to give them light. And the way they would produce this flame is they would use a substance called calcium carbide. And water would drip down from up here into the bottom to produce the ethylene gas and calcium hydroxide. So this ethylene gas would come up through here. They would light it with a lighter and it would stay lit. You would have this flame on top of your head in this hat to provide you light. And that's how they would see when they were digging the tunnel. Well, I show you this equation because now that we're learning about reactions, we need to know how to balance these equations to make sure every time we look at a reaction like this, it's balanced. Let me teach you how to do that. First, why do we balance reactions? It's because anytime we have a reaction, there is a conservation of mass, meaning mass is neither created nor destroyed. We cannot create mass out of nothing, and we cannot destroy mass and make it completely disappear. So mass is never lost or gained during a reaction. Things are just changing forms. And that's why both sides must be balanced in terms of their mass. And it also ends up balanced in terms of their atoms. Let's take a look at this one as an example. We've got carbon plus hydrogen gas makes C3H8. This is propane. The way we balance equations is the first thing we do is we make a table. And I see that I have C here, and I also have H. And I'm going to make a table where I have the number of C and H on the left side of the reaction and the right side of the reaction. And so on the left side of the reaction, we have one C and two H's. On the right side of the reaction, I have three C's and eight H's. Now, I want these numbers of C's and H's to be equal on both sides. So let's just pick a place to start. Let's start with C. I see what is missing. I see that I need three C's, but I only have one on the left side. So I'm going to add and change coefficients to balance. And if I put a 3 here, all of a sudden now I have three C's, and my C's, my carbons, are balanced. I can only add or change coefficients. I cannot add or change subscripts. It's only coefficients. Because when we change coefficients, we're just saying that these things react in different proportions. And that's okay. We can adjust to whatever proportion is correct. Let's fix the H's now. On the left-hand side, I have two H's. On the right-hand side, I have eight H's. Well, to balance this, what number can I put here as a coefficient to turn this 2 into an 8? If you said, let's put a 4 here, a coefficient of 4, You were right. That gives us 8 H's, and now both sides are balanced. So the balanced form of this reaction is 3 C's, 3 carbons, plus 4 molecules of hydrogen gas make 1 C3H8. And remember, if I don't write a number, we can assume that this is just 1 here. Let's do another example. I see a reaction here between sodium, water, to make sodium hydroxide and hydrogen gas. But I want to know what proportion what ratios do these things react in? Well, let's make a table. I've got Na, I've got H, and I've got O. And remember, I should have the same number on both sides because we can't create or destroy any of these atoms. And on the left side, I got 1. On the right side, I have 1 for Na. For H's, on the left side, I have 2. On the right side, I have, look at how I have 1 here and 2 here. I have to add these up. So in total, I have 3 H's on the right side. Let's do O. On the left side, I have 1. And on the right side, I have 1. So it looks like we're mainly balanced except for our H's. And well, let's try to change up what we are doing here, put a coefficient here so I can get closer to balancing them. I see that I have 3 on the right side. Well, the only thing that would make sense is to put I could maybe put 1.5, but we can't put decimals to turn H into 3 here. So let's just try the lowest whole number that's closest to that, which is 2. Let's just try putting a 2. And when we do put a 2 there, I see that I have 2 times 2 H's. So in total, I have 4 H's. When I have 2 H2O's, I have 4 H's there. And I look to the right-hand side. Now I got to go back and fix my H's on the right-hand side because I have 3, but 3 is not the number I'm looking for. So I have 2 options. And then I just have to think about it for a second to see that if I put a 2 here, I can get my right-hand side to be a total of 4. But once I put that 2, not only do I need to change my number of hydrogens, but I need to change my number of O's, which is 2, and NA's, which is 2. Oh, and one thing that I forgot here is when I put a 2 here, I actually changed my number of O's over here. So once I put my 2 there, I actually have 2 O's here now. What's the last thing that's missing? My NAs need to be balanced. I have 2 on the right side, 1 on the left side, and I can easily balance that by putting a 2 here. Once I put a 2 in front of Na, I now have 2 NAs reacting with 2 H2Os to make 2 NaOH plus H2, and now all of my atoms are balanced. Let's do a couple of more. Let's do 2 more before we conclude and we practice in class. On this one, what is my first step? I'm going to write a table, and I want to balance my C, H's, and O's on the left side and right side. How many C's, H's, and O's do I have on the left side? I've got 1 C, 4 H's, and 2 O's. On the right side, what do I have for C, H's, and O's? Well, I've got 1 C here. I've got 2 H's here. For O's, I need to add up 1 here plus 2 here for a total of 3. Where do you think I should start? What do you think I should try to fix first? I could work here on the H's that aren't balanced, or work here on the O's. Because I have H's affecting multiple things, let's start with the H's because we could just fix the number of O's at the end. Because there's just one thing to change for the O's. And I want to get this to 4. Let's try putting a 2 2 here in order to get this to 4. Once my h's are at 4, what other element do I need to update after putting this 2 here? I now have 4 O's on the right-hand side. I see that my C's are good and my H's are good, and the only thing I need to do is fix my O's. And in order to fix my O's, if I just put a 2 here, that gives me 4 O's on the left-hand side. So now this is a balanced reaction. Let's do one more together. Or let me show you one more. What elements do I have on the left side here? I've got Na, Br, H, P, and O. I've got quite a few here. I'm going to make a big table. And how many do I have on the left side of each? Well, I've got 1 Ba, I've got 1 Br, I've got 3 H's, 1 P, and 4 O's. What do I have on the right-hand side? Well, I've got 3 NAs, 1 Br, I've got 1 H, 1 P, and 4 O's. I can start wherever I want in order to do this. I can start by fixing any of these, either Na or H. Those are the only ones that are not balanced. Let's try fixing the NAs first. And I want to get this number to be the same as the number on the right. So what number can I put here to get it to get 3 NAs? I can put a 3. And not only do I have 3 NAs, what other element do I have to change? I have to change my BRs. I have 3 BRs now. Well, I need to fix these two. I currently have 1, but I want them to be 3. And there's one number I can put here to change both of those at the same time, and it's 3. So if I put a 3 here, and if I put a 3 here, I change this to 3 and 3, and now we see that this whole thing is balanced. That's basically how you balance equations. And we're going to practice a lot in class, and some of them will get even harder, but we will go from there. Okay? Have a great day.